Okay, so let's then try the questions later. You'll give a try, and after that, let's discuss. Okay. In the experiment, I think we didn't write any note below it, right? We got the equation for, we compared the resistance. We compare the resistance R1 over R2 is equal L over 100 minus L. I think this is what we wrote finally. Right? Okay, so below that, let's write a few notes related to this experiment. Note. Note number one. When so in that experiment, can you remember this was the setup? We used resistors here, and here we had connectors, the connectors, and here we had a wire. Below, we had a galvanometer circuit. So comparing this length L and 100 minus L, we can compare these two resistors R1 and R2. In this case, we omitted this portion. These connectors are going to have certain resistance. These connectors are going to have certain resistance, but they are thick. Because they are thick, their resistance is low. When compared to R1 and R2, their resistance is low. But if we use small resistors, small resistance value, in that case, we cannot omit the resistance of these strips. Therefore, what we have to do is we have to omit using low resistors to compare using a meter bridge, since this resistance of those connectors cannot be neglected. Okay. When comparing resistors, they should not be small values, since the resistance of the thick strips, thick connecting strips cannot be neglected. You don't need to draw this diagram, just this note is sufficient. That was to explain to you. Okay. Now, if R1 and R2, are large resistors, in that case, the current that is going to flow through this is very low. In that case, here we know that galvanometer deflects when there is a current flow through it, right? The galvanometer is going to deflect when there's a, sorry, this circuit should be here, right? Between these two. Okay. We should have the galvanometer circuit here. Now, when the current is very low, already the current through this resistor becomes low when the resistance is high. Then the current through this is anyhow low. Okay. Therefore, although the current may not be zero, there might be a very small current. Even then, we are not able to identify whether it is at zero or slightly away from zero. So if you are using very huge resistance, if you're using huge resistance here, then we will have to use a more sensitive galvanometer. When R1 and R2 are large resistors, a more sensitive galvanometer, a more sensitive galvanometer has to be used. Now, if you are finding an unknown resistor, this time we can use a resistance box, because we know using a resistance box, we are able to get the value. Okay, so to determine unknown resistance, R1 could be replaced with a resistance box. Say R. So the resistance box is R, and the resistor determine an R2 with the resistor to determine say X. When the balance length is found, R over X or X over R. X over R is determined, hence X is found. Fourth, when the balance length is L1 X over R is equal L1 over 100 minus L1. Now let's interchange X and R, the places where they were. When X and R, when X and R are interchanged, the new balance length is L2. So now it becomes R over X is equal L2 over 100 minus L2. So here we can find X from this. X is equal L1R over 100 minus L1. Let's say this is X1. And here let's find X2, that is equal 100 minus L2 over L2. Therefore, X is equal X1 plus X2 by 2. It's better to take an average, right? So when we do this, we minimize the error due to non-uniformity of fire. This method minimizes the error due to non-uniformity of the wire. Have you noted up this, both of you? Or should I scroll up? Fifth one, to increase the accuracy of the reading of the bridge balance point is obtained between 35 centimeter and 70 centimeter. 30 to 70. 30 and 70 centimeter. Now, in this meter bridge, our balance length can come anywhere in this edge or this edge or almost at the center. So in these cases, the balance length will be at the center. The balance length will be almost at the center when these resistors R1 and R2 are almost equal. Okay, then only they will be at the center. If one of them is dominant, let's say R1 is dominant than R2, then it will come to a edge. It will be somewhere over here. And if it is the other way, R2 is greater than R1, then it will be somewhere here. But we already discussed that it is better to have resistors with the same order, almost equal. Then the reading will be much accurate. So if both of them are almost equal, then their balance length will be somewhere in between. That is why we say it's better to take the reading between 30 and 70 centimeter. So the reading will lie between them. If it is not, then in the resistance box, we can change the value. So the reading will be somewhere in between these two. Is the idea clear? Sixth one, for accurate measurements, for accurate measurements, for accurate measurements, any correction should be considered. So in a meter bridge, this wire has a length of 1 meter. But there will be some portion of the wire that goes into those strips, those connectors. Here, this is 1 meter. There might be some portion of the wire that goes inside this strip. So let's say that is E1. And here, let's say this is E2. Then this E1 and E2, they are called the end corrections. E1 and E2, E1, E2 are end corrections. So when we do an experiment, if we are considering the end correction, then our results will be much accurate. For that, we have to first find out the end corrections E1 and E2, doing a separate experiment. So using two separate experiment, with two known resistors, let's say P and Q, E1 and E2 is determined. E1 and E2 is determined. So if you want to find, we can compare P with Q. Let's say that is equal, according to this case, let's say the balance length this is, let's say we had a balance length up to here, L, then the remaining will be 100 minus L, right? So here it will be L1 over 100 minus L1. And now let's interchange the resistors. So we get Q over P, that is equal, sorry, here it is L1 plus E. L1 plus E, now this is the length. And on the other side, this is the length. So that is 100 minus L1 plus E2. So for Q over P, it will be L2 plus E1. Sorry, this is L1. L2 plus E1, 100 minus L2 plus E2. from above, E1 and E2 can be determined. Already have written that, right? We have already mentioned it. Is it clear what I mentioned here? We have to find what is E1 and E2. For that, we have to do two separate experiments. So we use two known resistors, PQ. First, I put P in place of R1 and Q in place of R2. Then get the balance length. The reading is L1. So if this is L1, this will become 100 minus L1. Then the actual length will be L1 plus this E. So L1 plus E1. Here this length will be 100 minus L1 plus E2. So that is the first equation. The second equation, we interchange the resistors. So now it is Q over P, that is equal L2 new balance length plus E1 and 100 minus L2 plus E2. Now we have two equations. In this equation, here all of these are knowns. P and Q is known, L1 is known. Then only we have two unknown. If we have two unknown, we need two equations. That is what we have got. Therefore, we can find out what is E1 and E2. Is the idea clear? Saja, clear. Seventh note. Sliding key. Sliding key should not be pressed. Should not be overpressed. Should not be overpressed on the bridge wire. On the bridge wire. During the balance. To avoid deforming the wire, the uniformity of the wire. Let's look at an example. The balance length is 83 centimeter and on the other side is 17 centimeter. Here we have a resistor of 10 ohm and this is 2 ohm. Now we are going to find what is the end correction on both the sides, E1 and E2. So for this, we have to do two experiments. then we interchange the resistors in the next experiment. During that, we find what is the balance length. Two ohm and 10 ohm. It's 16 centimeter and 84 centimeter. The end corrections are E1 and E2. So let's find out what is E1 and E2. In the first equation, 10 over 2. 10 over 2 is equal 83 plus E1. E1 over 17 plus E2. That is equation 1. Or otherwise we can write 83 plus E1 over 17 plus E2 is equal to 5. That is the first equation. The second equation, 2 over 10. 2 over 10 is equal 16 plus E1. 16 plus E1 over 84 plus E2. So we have 1 over 5. 1 over 5 is equal 16 plus E1 over 84 plus E2. Let's simplify it further and get an equation. So here we have 83 plus E1 is equal 5 into 7, that's 5, 35, 85 plus 5 E2. So we have 5 E2 minus E1, 5 E2 minus E1 is equal to minus 2. 5 E1 minus E1 is equal to minus 2. That's the first equation. Second equation, 84 plus E2 is equal 50, 30, 90 plus E1. So E2 minus E1. Oh, sorry, it's 5E1. E2 minus 5E1 is equal 6. That's the second equation. So using the first and second equation, let's find out what is E1 and E2. I'll multiply the first equation by 5 and add with the second equation. So if I multiply this one by 5, 25 plus E2, that's 26 E2 minus 5 E1. We'll have to deduct, right? Minus second. So multiply this by 5, 25 minus E2, that's 24 E2. Multiply this and deduct, it's 0. Multiply this by 5 minus 10 minus 4. So E2 is equal minus 106. Is it correct? 5 into 6, that is 80, right? E2 minus 5E1, that is minus 4. Multiply by 5 and deduct this, you get minus 10 plus 4, that is minus 6. So E is minus 1 by 4. E2 is equal to minus 0.25. E1 from first equation, that is equal 5E2 plus 2. So 5E2 is minus 1.25 plus 2, therefore 0.75 centimeter. So those are the n corrections. Hope it is clear how to find the n corrections. Noted. The meeting might end now. Join quickly.